What would happen if the moon suddenly disappeared? People on Earth might not immediately realize the seriousness of the situation, but the creatures that are active at night would sense something amiss. The first night after the moon's disappearance would arrive 6 hours later, and people would likely have trouble sleeping. Scientific studies suggest that the moon's magnetic field significantly influences human mental activity. 10 hours after the moon vanishes, the absence of moonlight would make the stars in the night sky much more visible. A day after the moon's disappearance, tides on Earth would start to change. High and low tides would gradually reduce by over 75%, causing a severe impact on marine ecosystems, and some marine species would begin to disappear. 3 days after the moon's disappearance, due to the lack of the moon's balancing gravitational force, the Earth's axis would gradually start to wobble, altering its once stable 23.5-degree tilt. Weather would become exceptionally erratic, with severe conditions like strong winds and heavy storms becoming more frequent. 1 week after the moon's disappearance, Earth would become increasingly unstable. Tidal effects would collapse entirely, leading to enormous tsunamis in the oceans that would inundate coastal cities worldwide. 1 month after the moon's disappearance, celestial bodies from space would continually impact the Earth. These could range from meteor-like objects to asteroids large enough to cause mass extinctions. 3 months after the moon's disappearance, the previously stable crust structure, now lacking the moon's influence, would experience a violent release of long-accumulated forces. Severe earthquakes would occur globally, and the major tectonic plates would begin to shift. 6 months after the moon's disappearance, the climate would undergo unprecedented changes. The world would no longer experience the 4 seasons, as an ice age would envelop various parts of the globe. In just half a year, the Earth would undergo a dramatic transformation. It's precisely because of the moon's significant influence on Earth that scientists have been particularly intrigued by its existence. On July 21, 1969, Neil Armstrong became the first person to land on the moon. After conducting chemical analyses of lunar soil samples brought back from the mission, scientists discovered that the moon likely formed from a celestial impact event about 4.5 billion years ago. During the early stages of the formation of the solar system, when Earth's surface was barren and completely covered in molten rock, a planet named Theia collided with Earth at high speed. This collision ejected a significant amount of debris from Earth, which, upon entering space, was captured by Earth's gravity and gradually coalesced, forming the moon. For the past 4.5 billion years, the moon has orbited Earth at a distance of approximately 384,000 kilometers, serving as Earth's lone companion. It has witnessed Earth's transformation from a planet with an 8-hour day to one with a 24-hour day, and it has observed the Earth's long and complex evolutionary history. Today, the moon is slowly drifting away from Earth at a rate of 3.8 centimeters per year. If you've ever observed the moon closely, you might have noticed that one side of it always faces Earth. This is known as the famous tidal locking effect. As for what's on the far side of the moon, we've learned from lunar photographs returned by probes that it is covered in a dense array of impact craters. Each of these craters is a result of a catastrophic collision. In the perilous expanse of space, the moon has been silently guarding us. Had these impactors struck Earth instead, the existence of humanity might have been in question.